So we are in section 8.4, and I just want to remind you guys of what we talked about on Friday, which is basically 3 rules of fractions that you just have to know. Okay, there's got to be givens. Okay, so first off, simplifying fractions, we can only simplify factors, things attached to each other by multiplication. You cannot simplify terms, which are things attached by addition or subtraction. Okay, and they simplify as a 1-to-1, one from the top with one from the bottom. Okay, that's the only way we can reduce fractions. Multiplying fractions, you multiply straight across the top, so you multiply the numerators together. And you multiply straight across the bottom, so you multiply the denominators together. That is how we multiply fractions, okay? And then lastly, we are dividing fractions, and the key on dividing fractions is that we don't do it. You don't divide fractions, okay? They're asking us to divide by this fraction. Well, we don't do that, so instead we multiply by that fraction's reciprocal. Okay, and once you have it rewritten as a multiplication problem, then it becomes exactly like we did for multiplication. Just multiply the numerators, multiply the denominators. Okay? So let's see how this is going to look with rational expressions. So on the back page of your notes, that first problem says, what is the product of those 2 rational expressions, those 2 big fractions? Okay? And the first thing I would want you guys to do is I would want you to multiply these together to get one big fraction. Okay? And that is very easy to do. Don't overthink this. Do not try to FOIL. Do not try to take the x squared times the x squared and so on and so forth. Don't do that. Simply write it as x squared plus x minus 6 times x squared minus 25. There, I multiplied the numerators together. And now I do the same thing for the denominators. I have x minus 5 times x squared plus 4x plus 3. So now I have it written as one big fraction. Now I need to reduce this one big fraction. Okay, so like we learned last week, to reduce this fraction, we've got to go and factor each item. Okay, so I've got to factor this first trinomial, x squared plus x minus 6. It's a trinomial, so therefore we know if it factors, it's going to factor into 2 binomials. And what are those 2 binomials? How does that factor? X plus 3, x minus 2. Because again, we're looking for 2 numbers that when you multiply them give you a -6, but when you add them give you a +1. Okay? Well, now we're looking at that second binomial on top, x squared minus 25. Say it again, how's that factor?
X minus 5, x plus 5.
That's exactly right. X minus 5 times x plus 5. Okay, well now we need to take a look at the denominator. Is there anything we can do with the x minus 5?
No.
Nope. And then how about that last trinomial? Again, the shortcut says we're looking for 2 numbers that multiply to give us 3, but add to give us 4.
3 and 1.
So it's going to be x plus 3 times x plus 1. Any questions on getting to this point? Okay, well all we do now is reduce it down. So what cancels? X plus 3 from top and bottom, and x minus 5 from the top and bottom. And so our final answer is x minus 2 times x plus 5 over x plus 1. Any questions? Now, if you guys are given a problem like this on a standardized test, a state test, or an ACT, or SAT, or anything like that, or maybe you're looking this problem up in the back of the book to see if you got the problem right, okay? You've got to recognize that this is the same thing as saying this. These are the exact same thing. The way I got that second one is that all I did was I FOILed those two binomials on the top together. Okay? So if you are looking at an answer in the back of the book and you're like, well, wait a minute, that's not what I got. Well, is this the same thing as this? If it is, then you're right. I don't need you guys to multiply this out. This is a perfect answer. Okay? But you've got to be able to recognize alternate forms of that same answer. Because let's say this was a multiple choice test on an ACT. They might give this as the answer. I don't want you sitting there going, well, it's none of these. You've got to recognize equivalent forms of the same answer. Okay?
Could you also do like -2 plus 5 and -2 times 5 to get those numbers?
That's exactly how I did it.
Okay.
That's exactly how I got this. I just, foiling it out is the long way. We now know that shortcut, so you can also multiply that same way. Yep. Okay, so there we go. Any questions on how to get to here? No? Let's try another one. All right, the one right below. So again, first thing we want to do is we want to rewrite this as one big fraction. So I have 2x minus 8 times x squared plus 5x plus 4 over x squared minus 16 times x squared plus 8x plus 16. So now I've got them multiplied together. It's one big fraction. Now we've got to reduce our one big fraction. And the way we do that is by factoring everything. So looking at our first binomial here, is there anything we can cancel out, or I'm sorry, not cancel, anything we can factor out of 2x minus 8? A 2, yeah. This is going to be 2 times x minus 4. Well, now we've got a trinomial here. So if it factors, it'll factor into 2 binomials. And what are our numbers in there? Positive 4, positive 1. Okay, well now we want to look at that x squared minus 16. How does that guy factor? Yep, x plus 4 and x minus 4. And now we have that last trinomial. How does that factor? Yep. X plus 4 and x plus 4. Bless you. So now we need to go through and simplify. Well, it looks like I got an x plus 4 on the top and bottom I can cancel. I've got an x minus 4 on the top and bottom I can cancel. And that's all we can do. Please remember, you cannot cancel two things that are both on the bottom or both on the top. It has to be one from the top with one from the bottom. Okay? So that means we are done here. We get 2 times x plus 1 over x plus 4 times x plus 4. That is our answer. Now again, you might see this written differently if you're taking an ACT, SAT, or looking in the back of the book. They might have this written as 2x plus 2 over x plus 4 squared. These are the exact same thing. You've got to be able to recognize them as being the exact same thing. Okay? Any questions? No questions. Okay. So then, let's move on to division. Okay. So first thing about a division problem is that we have to rewrite it as a multiplication problem. Okay. So I'm going to go through and say 2 minus x over x squared plus 2x plus 1 times the reciprocal of that second fraction. X squared minus 1 over x squared plus 3x minus 10. Okay, and right there we're pretty much done with the division part of this problem. Because now we've rewritten it as a multiplication problem, and so now this has worked exactly like the previous two problems we've done. Okay, so I'm going to rewrite it together. 2 minus x times x squared minus 1 over x squared plus 2x plus 1 times x squared plus 3x minus 10. And now I've got to reduce that fraction. So I've got to try to factor stuff. So looking at the first binomial here, can we do anything with 2 minus x? Actually, we can, folks. We can. We don't like our x's, our variables, to be negative. We don't like that. So what do I do? I factor out a -1, which then leaves me with a -2 plus x. How about that second binomial? What can I do with x squared minus 1? X plus 1 times x minus 1. It's a difference of perfect squares. Now we're looking at that first trinomial on the bottom. So how does x squared plus 2x plus 1 factor? Two numbers that multiply to give us 1 but add to give us 2. X plus 1 and x plus 1. How about our second trinomial? X minus 2, x plus 5. Excellent. Okay, so we multiplied the fractions together. We then factored all the parts that we could. We now need to simplify stuff down. Yes, sir?
I was going to say that you could do x minus 2 and -2 plus x.
Right, those are the exact same thing. -2 plus x is the exact same thing as x minus 2. So yes, those cancel out. Very good. What else cancels? X plus 1 from the top and bottom. But please remember, only one of the x plus 1s on the bottom go away. It's got to be 1 for 1. Okay? So does anything else cancel as we're looking here? Nope. So then I'm going to write that -1, I'm going to write that out in front of my whole fraction. So we've got negative x minus 1 over x plus 1 times x plus 5. Any questions? No? Feeling pretty good about this? Okay, so then the next problem, the last one on the page, I would like you guys to work that on your own. I'll give you about 2 minutes. Go. Okay, folks, I'm seeing a lot of good stuff here. There are a few things I want to cover. First off is I would like to show you guys how to work this problem, showing as much work is needed, but as little work as possible. Okay? So first off, in factoring, I would factor this before I do anything. So on your homework, you would write this problem down just the way it's written. Okay? And then right there on that problem, I'd go ahead and say, all right, well, how does this guy factor? Well, I need two numbers that multiply to give me 4, but add to give me 5. X plus 1, x plus 4. So I'm getting rid of that guy. Okay? On the bottom there, again, I need two numbers that multiply to give me negative 12, but add to give me positive 1. X plus 4, x minus 3. I need to factor x squared minus 1. X plus 1, x minus 1. And I need to factor 2x squared minus 6x. Okay, so I have factored all those pieces. So next, I want to go through and multiply my two fractions together. But I've got division here. So I'm going to change it to multiplication by making sure that I reciprocate that second fraction. So what I'm going to do, to show in my work, is I'm going to take this numerator times this denominator. And so I get x plus 1 times x plus 4 times 2x times x minus 3. Over, and then I'm doing the same thing, but this time I'm taking the the denominator here, times the numerator of the other. X plus 4 times x minus 3 times x plus 1 times x minus 1. And so that's just a way of getting us to this step without having to rewrite that problem 2 or 3 times. Okay? And again, the more you work these problems, the more you're going to see shortcuts like that as far as showing your work. I showed plenty of work to be able to, so that I could follow it on a test, or that I could follow it on a quiz, but it still isn't rewriting the problem 3 times. Okay? So now, we can go ahead and cancel. X plus 1 cancels with an x plus 1. X plus 4 cancels with x plus 4. X minus 3 cancels with x minus 3. We are left with a 2x on top and an x minus 1 on the bottom.